Hey everyone, this is CHM Classroom with Auntie Taiwo. Click on the subscription button. You cannot just view our videos and learn chemistry. You need to subscribe. So please press on the subscription button and let's get to class. Today we'll be doing oxidation number. I'll be mentioning oxidation number. I mentioned valency. At times I have mentioned some compounds, and so I'm going to expose us to the concept of the oxidation number this morning. Oxidation number have to do with the charge in which an element carries. Yes, and those charges can either be positive or negative. Yes, it can either be positive or negative. And the positive charge comes from metals that are actually willing to give out electrons. They have just small electrons at the atmosphere, either one, two, at times three, like aluminum. They are willing to give out the electrons. Why? The negative ones, they collect, they receive, they are not willing to give out because they have more electrons at the atmosphere. So they will want to struggle and fill up the octet structure. The maximum number of electrons at the atom shell is 8 from the second shell. So all atoms, all electrons, they want to hurry. Oh, I must get this 8. So some of them that have few electrons at the atom shell, like 1 or 2, they are willing to give out so that they will remain stable. While those ones that have above 4, they'll just look at, okay, if I have 5, I can get 3 from another atom. If I have 6, definitely somebody will be willing to give me 2. So that's the way it goes. So I have some elements on the board and I'm going to show you their oxidation number. So I have both for the positive and the negative. So we'll start with the positive. This is magnesium. Magnesium is 12. Calcium is 20. Okay. Then my aluminium is 13. Then my hydrogen is 19. I'm going to leave iron. I will explain iron later because iron is a bit different. Okay, so magnesium is 12. So I have 2, 8, 2. So automatically, magnesium is willing to give out this 2 and dash it out. So magnesium has +2. Okay, calcium also is 22, 8, 8, 2. So automatically it's giving out this 2 +2. Aluminium 2, 13, 8, 3 is giving out this 3. So it has +3. Aluminium is very generous. So yeah. So 19, you have 2, 8, 8, 1. Of course, potassium, what is it doing with this one? So to give out 1. But for iron, iron is a transition metal and it has what we call the variable oxidation state. Yes, their own is different. They are the D block elements of the periodic table. Their own is different. So iron can either be +2 or +3. So it uses these 2 oxidation states. So that was why I said their own is different. They are the D block elements on the periodic table. When we get to periodicity, we'll talk more about that. Then coming to the negative ones, oxygen is what? Oxygen is 8, chlorine is 17, nitrogen is what? Nitrogen is 7, sulfur should be 16, yes. So my oxygen, we have 2, 8, 2, 6, yes, 2, 6. So how many electrons does oxygen need to complete to 8? Is 2 electrons, so it will be -2. It will get -2 from any element, either by legal means or by illegal means. Oxygen will get that 2. So chlorine 2, 8, 7. Chlorine needs only just 1 electron at the atmosphere, so definitely is going to look for how to get that 1 to complete to 8. So chlorine is going to have what? -1. Nitrogen is 7, so 2, 5. Nitrogen still have a lot to go. 3 electrons, but of course aluminum will be willing to give out or it forms what we call the covalent bond at times with oxygen, So it has 2, 5, so it will be willing to collect 3 electrons, so that is what? -3. Sulfur is what? 16, 2, 8, 6. It needs how many electrons to complete for the valence shell? It's 2, just like oxygen. So we have what? -2. So we have been able to establish both for the positive and the negative atom. So when next we meet, we'll be proceeding to other aspect of chemistry. Yeah, thank